Hello, my name is Dale Ayers. This is my presentation for my cloud development website. The purpose of this presentation is to give an overview of my cloud development website and talk about the problems I ran into and the basic architecture of development. So to start, we started with containerization. The very first thing we did was we built a container on Docker, and then we used that container and we used it and put it on AWS, the cloud. Um, I define this as refactoring or re-architecturing. We just modify our um, website or application and move it onto the cloud in the best ways possible. This is where the value of Docker Compose comes into play. It simplifies configuration, multiple environment support, consistency across environments, convenient local development, efficient resource utilization, service orchestration, networks, and volumes. These are my containers that I used in this project. The best way I can describe Docker Compose and the advantages I see from it are I could just take this container and I can use it elsewhere. I can use it in AWS, I can use it on the Windows or the Google serverless platform, no problem. Next, we can just talk about the serverless cloud. A lot of people get confused on what serverless even means because the name itself is a bit counterintuitive. Serverless does not indicate that there is no server, simply that we are just using someone else's server. In this case, we're using Amazon Web Services. Now, to articulate the differences between Amazon S3 and a local storage is to simply state the difference between local storage and serverless architecture. And that is local storage is hardware-based solution that offers fast data transfers and accessible from a local network, but it requires a lot of manual maintenance and doesn't scale as an S3 website can naturally do. No problem. This is my S3 bucket. This is the main difference here is I can get on any web browser. If I have this URL, I can pull it up. I can start working on it no matter where I'm at in the world, as long as I have an internet connection. On the other hand, unless I have the laptop I'm on now, I can't work on my local architecture. And that's, I don't know what else to say. That's the main difference. Next, we can talk about API and Lambda. A serverless API simplifies operational management, scales automatically to meet demand, allows developers to focus on writing application code, reduces cost by charging only for compute time used, and provides built-in high availability and fault tolerance. And what is a Lambda, and how do they relate to each other? The best way I can describe how an API and a Lambda relate to each other is when you make a call to a website. So let's say you want to access some part of the database. So you would send it a GET request. When the GET request happens, something on the back end has to happen. That something on the back end is a Lambda function. Because a GET by itself isn't really anything, it's just a request. The Lambda function itself is what will get us that request, or a post, or a delete, whatever that might be. That's the best way I can describe this relationship. Database. MongoDB versus DynamoDB. The best way to describe the differences in these databases is that they're pretty similar. They're both NoSQL databases. They both use key value pairs. The main difference that I can glean from the two is that DynamoDB is optimized for scalability, just like everything on Amazon Web Services, scalability. Here's an example of the key value pair. Here's the key ID, and here are the value, and here's the value, the ID. Here's the key, negative votes. Here's the value, 0. So if I were to search, ID, this is what I would get back. If I were to search negative votes on this ID, this is what I would get back. Let's talk about elasticity and the pay-for-use model in a cloud-based environment. Elasticity simply means, do you have the amount of bandwidth for the amount of traffic that is going to come to your website? So a great example of this is an e-commerce website. E-commerce websites have a steady flow of traffic until Christmas time, when they have suddenly a lot of traffic that they need the bandwidth for. Now, if we didn't have a cloud-based serverless architecture, we're going to have to build that infrastructure locally and have all this wasted bandwidth for no reason. Elasticity in a cloud-based environment handles this, and how the pay-for-use model works, and how it relates to this idea that I'm trying to present to you, is that when that Christmas time comes, we haven't paid for what we don't need until we pay for when we need it. In a cloud-based environment, AWS, other providers, they have the infrastructure set up, and we just pay for what we need. Securing your cloud app access. How can you prevent unauthorized access? Preventing unauthorized access involves a multi-factored approach, which includes implementing strong authentication and authorization mechanisms, using encryption for data at rest and data in transit, employing firewalls and intrusion detection/prevention systems, keeping software and systems updated regularly, auditing and monitoring systems activity, practicing the principle of least privilege, and educating users about security best practices. Now, in the context of this project, all of that is kind of out the window, and we focused mostly on policies. Explain the relationship between roles and policies. In the context of cloud computing, and particularly AWS, a role is an AWS identity that can be created in your account, which has specific permissions. It is not associated with a specific user or group, but is meant to be assumable by trusted entities such as AWS services, an application, or even a user from another account. A policy, on the other hand, is an object in AWS. When associated with an identity or resource, defines their permissions. AWS evaluates these policies when an entity or user or application makes a request. Permission in these policies determine whether the request is allowed or denied. This is the IAM policies. So the relationship between these roles and policies is to attach these policies to roles to define the action, resources, and services that the role can interact with. And I have an example of this at the end of this slide. And this was the main problem I had with my project. I could not get the roles and policies to work correctly. I tried and tried and tried, and I could never figure it out. And looking at it from a security perspective, as a security guy, a wannabe security guy, I guess. I could see how insecure websites are made all the time, because you just probably just get to the point where you're so frustrated, you're just ready to send it out, insecure or not. I tell you what, I was at that point in this project. And we're going to touch on API security. How can you secure the connection between Lambda and the API gateway? From my research, there are 6 ways to do this. The IAM roles and policies, which we covered in this project. Resource policies. And we did do this. These are Lambda policies, where we implement JSON code into the Lambda function. And we did this. And you can change this around or do whatever you need to do. API gateway authorizers, API keys, encryption, VPCs, and web application firewall. I guess we don't really need to talk about all of those. We just need to talk about the 2 that we played around with, was resource policies and IAM roles and policies. Those IAM roles and policies really were a thorn in my side in this project. It really was the main problem. I could not get them to work. I do not know what was wrong with them. On the other hand, I didn't have much trouble with the resource policies. You just put the policy into the JSON file inside the Lambda. You can manipulate it how you see fit, and then you just run a test on it. And what are some custom policies created? Here's my my permission policy. Here's the Lambda access to question and answer tables. And this is what I was talking about, where you connect one to the other. You connect the role to the policy, and they're married. They're happily married. In conclusion, I wanted to show this photo from the beginning of the project, because I think it simply shows what we're doing here. This is my local project. You can see localhost 4200. I'm running it from my laptop. No problems, no issues. It works just fine. But unless I'm running it on my laptop, I can't access it. I can't edit it. If this were my late stage final project that actually worked, which I could not get to work, I could access it from anywhere. I could edit it from anywhere. I could scale it up. I could scale it down. There's just so many more options with cloud-based infrastructure. Now it is simpler. Or it's supposed to be simpler to throw it up on the cloud, spin it up, get it going. But as you can see from the problems I had in my project, there's some nuances that you don't really have to deal with whenever you're on your local host, and it's probably the same one the other way around. Just in my particular case, I ran into the problem with the roles and policies, and I could not get them to work. But broadly, we're talking about. I just wanted to show this juxtaposition here. And with that, thank you very much, and thank you for your time.